Welcome all my viewers. Today we are going to learn how to solve quadratic equations using graphical method. So we are going to start with this example here, where we are told to draw a graph of a function y equal to x squared plus 5x minus 6 for x greater or equal to negative 7 but less or equal to 2. We must state the coordinates of the vertex. Now, this is a quadratic equation, as you can see. Remember, quadratic equations are given in a form of ax squared plus bx plus c. So this is also a quadratic equation. So we must find the vertex of a quadratic equation. Remember, the vertex is the turning point. It can be a maximum or a minimum, as we are going to see in this example. Now, we have been given the values of x from negative 7 to 2. When they say x is greater or equal to 7, that means we start from 7, then we stop at 2, because x is less or equal to 2. So we first do our table, as I have drawn mine here. You do that table. When you draw it, you put all the values of x from negative 7, negative 2. Now we are going to break this equation into independent terms. First, we have x squared. I've written it here. We have plus 5x. I have written it here. Then minus 6. So when we do that, we are going to fill each space here. We are going to first get x squared. X squared means negative 7 squared. That is negative 7 times negative 7, giving us 49. Negative 6 squared is 36. Negative 5 squared is 25. We are going to complete the table as you can see. So the table is complete for x squared. Now what about 5x? We are going to find 5 times x. Now our x is negative 7 up to 2. So we are going to fill this space here. There, these spaces must be filled. So 5x means 5 times negative 7, which is negative 35. This is negative 30. This is negative 25. This is negative 20. This one here is negative 15. This one here is negative 10, negative 5, 0, 5, and 10. Then we have negative 6 is a constant. We don't have the variable x on it, so it remains negative 6 throughout. So we fill with negative 6 in all the spaces here. So we are going to find the values of y. Remember, y is x squared plus 5x minus 6. So we are going to get this. We add this. We subtract this, as you can see. So when we take 49 minus 30, because plus minus 35, that is like minus 35. Then minus 6. Press the calculator. This will be 8. This one here, we have 36 minus 30 minus 6, definitely this is 0. 25 minus 25, that is 0. Then minus 6, you get minus 6 here. Here, you get negative 10. Here, we get negative 12. Even here, we get negative 12. Here, we get negative 10. Here we get negative 6. Here we are going to get negative. No, this is 0, because it is 1 plus 5, 6 minus 6, 0. This is 14 minus 6, which is 8. Now our next step is to plot these values on the graph paper. We are going to plot a graph of x we are going to have to draw a graph of xy. We plot the values. Here the coordinate is negative 7, 8. So let us get our graph paper and we see how the graph will look like. So this is my graph. We have y and x axis. So we are going to find the point negative 7, 8. Now negative 7, 8, the point is here. Here we have negative 7, here we have 8 as the y coordinate. Here negative 6, 0, the point is here, already indicated. Negative 5, negative 6, negative 5 is here, and negative 6 is here. Negative 4, negative 10, negative 4, negative 10, the point is here. Negative 3 is here, and negative 12. So this one is negative 1, negative 10. We have 0, negative 6 here. We have 1, 0, the point is here. 1, 0, the point is there. And 2, 8, our point is here. So that means that we have our graph opening upward. So it will have a minimum point somewhere here. So we are going to draw a smooth curve passing through all the points. Let us do that. So this is our smooth curve passing through all the plotted points which we have got from our table here. Now we are going to find the vertex. Our vertex is the turning point, and you can see that when the curve changes direction, initially the curve is sloping downward, but after reaching a certain point, it turns and changes direction. So we have a turning point here, and that is our vertex. So we must read the coordinates here. So our vertex here, you can see, if you look it clearly, it will be negative. Our x coordinate is going to be negative 2.3. So the vertex x is negative 2.3, and the y coordinate is, when you look it properly, it will be negative 12.4. Negative. So you have to draw it on a graph. Get a graph book, you draw it, and you read it clearly if the screen is not clear. But mine, I'm getting 12.4. That is how we get the vertex. That is the turning point. Now you can see that the graph cuts the x-axis at negative 6 and at 1, meaning that these are the solutions of the graphs. If they want you to find the value of x, remember this is the vertex. We have negative 2.3 and 12.4. Now assuming you are required to solve this quadratic function, what is the value of x? You can just read where the curve cuts the x-axis. The curve cuts it at negative 6 and at 1. Those are the solutions for the quadratic function here. Now let us look at example 2. We have a question here which says, draw a graph of y equal to 2 plus 2x minus x squared for values of x from negative 2 to 4. We have our table already drawn from negative 2 to 4. Now, as we did in the previous example, we write the independent terms. We have 2, we have 2x. Now, we are going to have x squared and then minus x, and we fill all the spaces we get the y coordinates. So you pause the video and you complete it. Let me give you some minute to pause the video and complete it. Well, hope you have got all the values, you have filled all the table as mine. The next step here, we are going to plot our graph. So we have the value of x and the value of y. Here we have -2, -6, -2 and -6. The point is here. We have -1, -1. So -1 is here and -1 is here. So the coordinate point is here. 0, 2, 0, 2. The point is there. Then 1, 3, the point is here. 2, 2, the point is there. 3, -1, the point is here. And last 4, -6, the point is here. So we are going to put our curve. We are going to join all these points with a smooth curve. Then we answer the given questions. So if you are moving together, pause the video. You plot this one on your graph paper and you draw a smooth curve. Again, I'm giving some time to do it. Pause the video. Just pause the video. Hope you have obtained a curve which looks like mine. You can see that the curve has a maximum point. It is like a mountain. The previous example we had a minimum point. The vertex was minimum. Let us answer the first part here. The first part says find the maximum of this function. The maximum is this point here of y equal to. So the maximum, so because this is the maximum point and you can see that this one is 3. So the maximum of our function is 3. So our maximum is 3. Part B. The value of x for which y is greatest. Now, the value of x for which y is greatest and instead the coordinates of the vertex. Now, they want the value of x. Remember, when you read this graph here, this is 0, 2, 4, 6, meaning that in between here we have 1. So the value of x is 1. And state the value of the vertex. Remember, we are reading this point here, and this is our vertex. The value of x is 1, and the value of y is 3. So the vertex coordinates will be 1, 3, because x is 1, y is 3. Now the range of values of x for which y is positive. Now y is positive starting from here going upwards. Now the range of values of x. So when is y? Remember the curve falls in the lower part of y, which is negative, and the upper part, which is positive. So when they want to get when they ask us the range, we must find this upper part here. This is the part needed. Please don't say, just some shading to indicate. So this is the part of our function which is positive. This lower part here is negative, but the upper part there is positive. This is negative. So the range of values of x, so that means from here, this value of x here up to this value here. So when you look at that one, part C, we are going to have from x equal to, when you read from here, now this small, because these are 10 small boxes, giving us -2, meaning one comma box will be 0.2. So these are 1, 2, 3, 4. So this is 4 smaller boxes times 0.02. We have from x is equal to -8 to x equal to This is 2, 1, 2, 3, this is 2.8. Learn how to read the graph. So that point of the value of x is 2.8. So y is positive. Y is positive for x equal to negative 8 when x is greater than negative 8 but less 2.8. So we have answered that one also. Yes, for this we are not going to go through it step by step, but we are almost following the same procedure like the previous two examples. Here we are finding, we are going to solve. Whatever they say solve, remember from the previous two we are not told to solve, but to solve it, it is very easy. Solve this quadratic function. You follow the procedures as we did. You get our table. We plot the values of x and y. So you get the points for all the coordinates, and you put a smooth curve as you can see. Once you obtain that, now the solutions are here. Where does the curve cross the x-axis? Remember, we can find this solution by using a formula. Yes, sometimes you call it a bulldozer method. You can use computing squares, you can use factorization. Now we are using graphical method. We get the value of x. It is a quadratic function, or is the answers appear in pairs? The values of x, we may have two values. Because it is a quadratic equation, we always have two values. Now here, where the curve cuts the x-axis is our first solution, and the second solution is when x cuts the curve cuts the x-axis again. So we shall be having the values of x. X will be equal to, for this case here, please, you can come up to this step following the previous examples. Draw a table, plot the values, then put a smooth curve. Now look for the positions where the curve cuts the x-axis. So the first x value is -1. I've got it from here. The second position is here. It is 2. So, and those are the range of values. As you have seen, let us go back. Now here, the solutions are here. If you want to find the solution for this quadratic function here, you read this value and this value. From the first one, you read this one here and this one here. So the solution is -6 and 2. Hope it is clear. Yes, they can bring this number in different ways. Now here they are telling you to use the graphical method to find the roots of the quadratic equation. Now, again, we have a quadratic equation here. I break it into the different independent terms. 4x squared minus 12, then plus 9. You get the values of y. We have from -1 to 4. So we plot our graph. This is -1, 25. -1, 25. Please have to choose a suitable scale, and you plan for your graph. As you can see here, that the highest value of y is 25, and the smallest is 1. So I need the upper part of y more than the lower one. That's why my graph looks like this. My axes have been drawn like this. So you have to plan before drawing or getting your scale. And now I cannot use 1, 2, 3, 4. I cannot use 2 because the value 25 is very big. So I took 5, 10, 15, 20, 25. Even after two big boxes. So you need always to learn how to get the appropriate scale. So when you do that, you get your curve when you put the values here. Now find the roots of the equation. You can see that here the curve touches our x-axis. Yes, now let us look at a more complicated one. Here, actually it is not difficult, I've said complicated. Why am I calling it complicated? We've been dealing with quadratic functions here, but now what if we need to solve a quadratic function with a straight line? So here we are obtaining the solution, or we are solving a quadratic function and a line. Where do they meet? Obtaining the point of intersection. Where they meet, you read the x values. Those will be the solutions for the two. One a curve, one a straight line. Now look at this question here. Draw a graph of y. If you remember, we did this one already. Only that we have a y equal to x minus 4 on the same graph. So you must find the values of y equal to x minus 4. That's why you have a second table here. My second table here, I have x from negative 2. We are given the range, negative 2 to 4. Now from negative 2 to 4, we get the values of y, as you can see. Now this y is x minus 4. So this is minus 2 minus 4, giving us a negative 6 here. Here we get a negative 5. Here, negative 4. 1 minus 4, that is negative 3. 2 minus 4, we get negative 2. 3 minus 4, we get a negative 1. And 4 minus 4, we get a 0. So, we plot our points. Negative 2, negative 6. Negative 2, negative 6 for the straight line. Remember, for the curve, we can do it. We did it already. Don't forget. If you have forgotten, check, rewind, and go back. But we can get it from here. Negative 2, negative 6. You plot the curve first. Then after, you plot your line, because you have a line. So, negative 1, negative 5. The point is here. Negative 1. Sorry. Negative 1 for the straight line. We have negative 1, negative 5, the point is somewhere here. Though for a straight line, you need only 2 points to get it. So here we have enough points. So, with 0, negative 4, 0, negative 4, the point is here. We have 1, negative 3, 1, negative 3, the point is somewhere here. Not indicated, it was there. We have 2, negative 2. 2, negative 2, the point is here. We have 3, negative 1. 3 and negative 1. This is a negative. Then we have 4, 0, 4, 0. So we here I used only 4 points. We can use even 2 because this is a straight line. Yes, to go through all the points. So we get our straight line. Do you see that our straight line is intersecting our curve here? This is when this curve is equal to this line. That's why they're telling you to use the graph to solve 2x plus 2x minus x squared equaling to x minus 4. So here, the curve and the straight line are intersecting, they are equal. So the value of x and the value of x here are the solutions. So if we want to solve, we say x is equal to, here where they meet, they meet at negative 2, negative 6, where x is negative 2. And x, another point of intersection, we have x3, y is negative 1. So, we need the value of x. So, that is the solution. The solution for the graphs of this and this, curve and a straight line, we have x equal to -2 and x is equal to 4. Now we have these questions. Try out. This is our exercise. Try to do it. So this is our exercise here. You can see that we have the curve here and the straight line, the one we have just completed. We have here use a graphical method to solve. Now this is just a curve. Get the values of x from -3 to -4. So it is very easy. Yeah, these are numbers you should smile whenever you meet them in the question paper. So try out these numbers. They are not difficult. Here you are just completing the table. This is very easy. The table is even drawn for you. You just have to, this is 2x squared. I don't know what is here. You do it. Well. So that is how we solve quadratic equation by the graphical method. Previous method we have factorization is a method you use computing squares. So use the formula, computing squares, and the factor method now. Those are the 4. So hope you have enjoyed the lesson. Try this exercise. If you have not understood, please feel free to rewind. And any question, don't worry, you can call your teacher 0700642158. Teacher Isaac. Yes, you can send me WhatsApp on that number. This is Yugi, Uganda.